Now let's just see the next question. Question number 2 says that a 1.5 meter tall boy, he's standing at some distance from a 30 meter tall building. The angle of elevation from his eye to the top of the building increases from 30 to 60 as he walks towards the building. Find the distance he walked towards the building. So let us suppose if I'm starting by drawing the figure for all this question. So let us suppose this is my building. This is my building, which is actually 30 meter tall, and let us suppose if I'm taking the boy as 1.5 meter tall. So let us suppose this is the boy who is 1.5 meter tall. So let us suppose if I'm taking the boy's height as 1.5 meter tall, and let us suppose if I'm joining the both of the boy and the foot of this particular building. So as you can see, this building is a total of 1.5. This is a total of 30 meter. So let us suppose if I'll write it over here, this is nothing but a total of 30 meters. This is 30 meter tall building, and now we know that the angle of elevation which is given to us in between the eye of the observer and the top of the building is nothing but increasing from 30 degree to 60 degree. What does it mean? It means that let us suppose if the boy is standing over here, so he actually moved towards the building. Let us suppose he moved in such a manner over here. Let us suppose if he moved towards the building in such a manner, then the angle of elevation increases from 30 to 60. Means this angle was first of all 30 degree, and when he walked towards the building, let us suppose if he is at this particular point right now, then the angle of elevation is 60 degree. So let us suppose if I am marking this particular point and I am joining this with the horizontal. So this particular angle is actually nothing but 60 degree. This is 60 degree, and let us suppose I am making this particular line which is parallel to the horizontal ground. Now further, what we have to calculate, let us suppose if I am calling it as A, I am taking it as B, I am taking it as nothing but C, I am calling this one as D, I am taking this one as E, and I am taking this one as F, and let us suppose further I am taking a perpendicular over here as well. I am taking a perpendicular over here as well, and I'm just taking it as X. So basically we just have to find out this XB, that how much distance he actually walked towards the building. So this is the point where he actually looked at the top of the building and he made an angle of 60 degree, and that is the angle of elevation from the eye of the observer to the top of the building. So this is his final point. So we just have to calculate this XB. So let us suppose if I'll write it over here, we have to find this XB in total. Now as you can see, if this is 1.5 meter, so this is also 1.5 meter, and this would be also of 1.5 meter. From this particular diagram you can definitely see this AB is actually parallel to this one, this is actually parallel to this one, they all are equal to each other. So this is 1.5 meter. So hence if DF is nothing but 1.5 meter, then we can able to find ED, because we know that EF is actually is equal to ED plus DF, and we know that EF is total 30, which is equal to ED plus of DF. So from here we can calculate the value of ED. So ED would be nothing but is equal to 30 minus of 1.5, which is definitely nothing but 28.5. So hence this is ED. So ED is at the end we are getting as 28.5. So let us suppose if I'll write it over here, this is nothing but 28.5, because it is of really important information to us that AD is nothing but 28.5, because after using this we will calculate the value of CD and AC as well. Now let's just talk about finding out the total AD, how we can calculate the total AD. So let us suppose if I'm talking about in the triangle ED EDA, in the triangle EDA. So we have the triangle EDA. As you can see, for this particular triangle, this is my perpendicular, this is my base, and this is the angle theta. So let us suppose if I am just taking this particular angle as a theta 1. So let theta 1 is actually 30 degree. Let theta 1 is actually 30 degree, and we know that tangent theta or tangent theta 1 is nothing but is equal to perpendicular by base. Here perpendicular is ED and base is nothing but AD. So tangent theta 1 is nothing but tan 30 degree, which is equal to ED. ED is nothing but 28.5 divided by AD. So now we know that tangent 30 is nothing but 1 by root 3, which is equal to 28.5 by AD. So from here we have calculated AD. AD is nothing but 28.5 root 3. So the value of AD that we are getting is nothing but, the total AD we are getting is nothing but 28.5. So this whole distance we are getting is nothing but 28.5. So let us suppose if I'll write it over here, if this is 28.5 root 3, so this is also 28.5 root 3. So let us suppose if I'll write it over here, this is total nothing but 28.5 root 3, and the distance is in meters. So AD is nothing but 28.5 root 3 meters. Now let's just move on further and talk about this particular CD. We can calculate this CD. Now let's just talk about in the triangle EDC. In the triangle EDC, let us suppose let theta 2 is nothing but is equal to 60 degree. So again we can use the tangent as tangent theta 2, which is nothing but is equal to perpendicular by base, which is nothing but ED by DC. Now tangent theta 2 means tangent of 60 degree, which is equal to ED. ED is nothing but 28.5 again, and we have to calculate DC. We know that tangent 60 degree is root 3, which is equal to 28.5 DC. Now the value of DC would be nothing but 28.5 by root 3 meters. So this is the value of DC. So we know about the value of DC. Now hence we can calculate the value of CA in a very easy manner, because if this is 28.5 root 3 and this is nothing but 28.5 by root 3, then we can calculate the value of AC. Now let's just see how we can calculate it. We know that DA is nothing but is equal to DC plus CA. DA is nothing but 28.5 root 3, which is equal to DC's 28.5 by root 3 plus of CA we just wanted to calculate. So let's just CA is nothing but 28.5 root 3 minus 28.5 by root 3. Now let's just take this value common. We can take 28.5 common out of it, and then we will get the answer as root 3 minus 1 by root 3, which would be nothing but 28.5 root 3. Root 3 is nothing but 3 minus 1, so this is nothing but 2 by root 3. So hence at the end we are getting the answer as CA is actually nothing but, let's just multiply all these values. So this would be nothing but 10. We have this as 10. 0.2 into 8 is 16. 16 and 1 is 17. So this is 7, and further we have 2 into 2 is 4 and 5. So we have 57.0 divided by root 3. Let's just rationalize it. This is root 3 into root 3. Further we have 57 root 3 divided by 3. We can cancel the values as 3 into 1 is 3, and further we have 3 into 9 is 27. At the end we are getting CA as nothing but 19 root 3. And if CA is nothing but 19 root 3, it implies that XB is also is equal to CA, which is 19 root 3 meters. So hence at the end we have calculated the distance he walked towards the building. So the distance he actually walked towards the building, which is nothing but XB, is 19 root 3 meters, using the concept of the trigonometric angles and the angle of elevation as well. So this is all about the question number 2.